Hey, you're watching Reality Check, the weekly GameSpot show all about the sexy union between science and video games. This week, could playing video games make you more smarterer? Okay, so the answer really depends on what type of game you're talking about and also what attribute of intelligence you're looking at, because remember, intelligence or smarts is actually quite a broad thing. So this week I scoured the literature and dug out 4 fascinating bits of science which argue that video games have the ability to positively affect our brains. First up, perhaps the most compelling study I've seen on the topic examined the impact of playing real-time strategy game StarCraft on the test subject's level of cognitive flexibility. So what is that? Well, put in other words, cognitive flexibility is the ability of a person to quickly adapt and switch between tasks, but also to think about multiple ideas at one time to solve problems. It's a core component of our overall cognition. For the experiment, the researchers recruited 72 volunteers and tasked them with playing a specific video game for 40 hours over a period of 6 to 8 weeks. They were split into 3 groups. 1 and 2 played StarCraft, while Group 3 played The Sims. Now, the reason The Sims was chosen for comparison's sake was because of the comparative lack of memory or tactics required to play it. Ultimately, the study demonstrated that the subjects who played StarCraft were quicker and more accurate in performing cognitive flexibility tasks than those who played The Sims. The theory being that rapidly paced real-time strategy games can actually promote our ability to think fast on the fly and learn from past mistakes. So this is actually kind of a big deal. So in the past, action games like Halo have been demonstrated to speed up our overall decision-making process. But this is the first time a study has made a convincing case for a more general aspect of our intelligence. Lead author for the study, Dr. Brian Glass, argued that the paper shows that cognitive flexibility, a cornerstone of human intelligence, is not a static trait, but can be trained and improved using fun learning tools like gaming. Dr. Glass also acknowledged, however, that more study is needed to properly explain these changes and whether these cognitive boosts are permanent or if they dwindle over time. Okay, but what about games at the other end of the spectrum? Could gaming on one of these also help benefit the old grey matter? Well, a 2013 study published in PLOS ONE, Enhancing Cognition with Video Games, a multiple game training study, investigated just that. This time around, the study participants were divided into 5 groups, with each group playing a specific mobile game an hour a day, 5 days a week for 1 month. Some groups played object matching games like Bejeweled, others got hidden object games like the Hidden Expedition, and others still played agent-based virtual life simulations like The Sims. After the month was up, the researchers challenged all participants to a wide variety of tasks. What they observed is that playing these games trained the participants to be better at real-world tasks which involved similar cognitive functions. For example, those who played Match 3 objects and spatial memory games had improved performance on visual search tasks. The researchers also tested for an overall improvement in mental aptitude as a result of playing these games, but unfortunately they didn't find any. Only the specific skills involved in the game actually benefited. Kind of like if you work out your bicep in the gym, sure, you might be better at carrying things, but you won't necessarily be better at running a marathon. Okay, so let's say there's a certain region of the brain that you want to train and improve. Could you pick an appropriate video game and use it to boost its function? Well, a study from October last year certainly suggests so. This time around, the game of choice was Super Mario 64, and the gaming guinea pigs in question assumed control of the Italian plumber for 30 minutes a day, every day, for 2 months. A very unfortunate control group, however, weren't allowed to play any games for this time period. Now, following the test, the researchers measured the actual volume of the subjects' brains. They discovered that in comparison to the non-gaming control group, the Super Mario 64 players showed an increase in the physical amount of grey matter, that's brain cells, in the regions involved in functions like spatial navigation, memory formation, strategic planning, and fine motor skills of the hands. And a fascinating little bonus detail is that those participants who reported more desire to play the game actually had even more pronounced changes in these brain regions. Okay, last one. Now, like roughly 10% of the population, I suffer from dyslexia. Now, I say suffer, mine's pretty mild, so it doesn't really affect my day-to-day life. Or is it affect? Anyway, what if I told you that playing 12 hours of an action video game did more for the reading skills of dyslexic children than is normally achieved within a whole year of spontaneous reading development or traditional reading treatments? Well, that is exactly what a study published in the February 2013 edition of Current Biology demonstrated. The kids in the study who played action video games were able to read faster without losing accuracy, and they also showed gains in other tests of attention. So why on earth would video games potentially help a child's dyslexia, you might be wondering? Well, the key is the relatively new idea that dyslexia might be linked more with early problems with visual attention rather than issues with language skills. Action games, you see, demand your complete attention for a sustained period of time. So the theory is that by playing the action games, it helped enhance many aspects of the children's visual attention, mainly improving the extraction of information from the environment. One of the study leads, Andrea Fassoetti, commented that their study paves the way for new remediation programs based on scientific results that can reduce the dyslexia symptoms and even prevent dyslexia when applied to children at risk of dyslexia before they learn to read. So, what do you guys make of these studies? And what type of future research would you like to see along these lines? Let me know in the comments box down below, or you can tweet directly at me at CamFrazRob. Okay, thanks for watching, science fans. See you next week.